Section 2.2, the coordinate plane and graphs of equations. Here we have the coordinate plane, and we're going to go over what makes up the coordinate plane and some key characteristics of the coordinate plane. So first, the coordinate plane is made up of two axes. The first is the x-axis. The x-axis is your dark horizontal line, and then we have the y-axis. Okay, the y-axis is our dark vertical line. Those two come together at a point. That point is known as the origin. Well, let's see if it'll let me write. Okay, the origin is the center. Okay, the origin has the ordered pair 0, 0. Okay, again, the origin is where the x-axis and the y-axis come together. Now, the x and y-axis come together and they break the coordinate plane into 4 regions. Those regions are called quadrants. All right, this first region right here is quadrant 1, and they're numbered counterclockwise. So over here we have quadrant 2. Down here in the left-hand corner we have quadrant 3, and then over here in the right-hand corner we have quadrant 4. So the x and y axis break up the grid into 4 quadrants. Now, there are things that we know about points that are in each quadrant. In quadrant 1, we know that the ordered pair is always going to have a positive x value and a positive y value. So let me write that up here. We have x and y, okay? Each ordered pair is written as a coordinate of an x value and a y value. In quadrant 1, we have both of them being positive. In quadrant 2, we're going to have a negative x value and a positive y value. In quadrant 3, we're going to have a negative x and a negative y. And then in quadrant 4, we're going to have a positive x and a negative y. Okay? So we have our 4 quadrants. There are times when a point doesn't fall in one of those quadrants, where it actually falls on either the x-axis or the y-axis. So let me put a point here, okay? This point right here does not fall in quadrant 2 or quadrant 3. It falls right on the x-axis, okay? That point right there is what's known as an x-intercept. X-intercept, okay? It's where it's a point that is on the x-axis. The way we write that ordered pair is we know the x value is 1 to negative 3, and the y value is 0. So whenever we have a point that lands right there on the x-axis, the y value is always going to be 0. Okay? So then we have points that land right on the y-axis. Well, that's called a y-intercept. All right, and a y-intercept is very similar to the x-intercept, but this time we know that the x value is 0, and we know this, and this one, the y value is negative 1, 2, 3, negative 4. Okay, so an x-intercept is going to be right there on your x-axis. A y-intercept is going to be on your y-axis. If you have an intercept, either your x value or your y value is going to be 0. Otherwise, we have points in each quadrant. Okay, so let's just kind of label a few points. Let's go ahead and plot the point 5, negative 2. Okay, we'll call that point A and we'll label it 5, negative 2. Well, you always start at the origin, and the first value is the x value, so that's telling you whether you're going to go left or right. Since it's positive, we're going to go to the right, so we're going to go to the right 5. 1, 2, 3, 4, 5. Then we have a negative 2. Negative 2 is the y value. Negative means we're going to go down, so we're going to go down 2. 1, 2. So my point is right here, point A. Okay, let's just go ahead and plot one more. let's plot the point. Negative 3, 4. Negative 3, 4. Again, we start right here at the origin. This time my x value is negative, so I'm going to go to the left 3, and I'm going to go up 4. 1, 2, 3, 4. And that is my point B. Okay? So that's the basics of the coordinate plane. Now that we're familiar with the coordinate plane, let's talk about symmetry. What I want you to do is pause this, and I want you to write x-axis symmetry and draw a grid. Go ahead and plot the point 4, 2, and then draw a new grid for y-axis symmetry and origin symmetry. And on each of those grids, make sure you plot the point 4, 2. Again, go ahead and pause this. All right. Now, x-axis symmetry. What x-axis symmetry means is that there is a reflection across the x-axis, okay? A reflection across the x-axis. All right, and we know that the x-axis is this horizontal line, okay? So here's the x-axis. If a graph has x-axis symmetry, and we know that the point 4, 2 is on that graph, then what we do is we reflect, we go right across the x-axis. So right now we're 2 away from the x-axis, so we go 2 away in the other direction. So we now have this point also on our graph, okay? Again, if we have x-axis symmetry, it's like a mirror image across the x-axis. So if I know the point 4, 2 is on my graph, and there's x-axis symmetry, then I also know that the point 4, negative 2 is going to be on my graph, okay? Y-axis symmetry is similar. We have a reflection or a mirror image across the y-axis. Can't spell. Okay, so here's my y-axis. I have the point 4, 2. Again, it's a mirror image, so it's like folding your graph in half right on the y-axis. If you fold your graph in half, it needs to match up with a mirror point on this side. So if I have the point 4, 2 on my graph and there's y-axis symmetry, I'm also going to have the point negative 4, 2. Let's see if I can get it to draw. Negative 4, 2. Okay, so notice, let's look back at the x-axis symmetry. In x-axis symmetry, notice the x value stays the same. And what happens is we have an opposite y value. When we have y-axis symmetry, the y value is going to stay the same, but we're going to have opposite x values. Notice a negative 4 and a positive 4. Now, origin symmetry is a rotational symmetry. Okay, sometimes it's a little hard to visualize, but basically if we have the point 4, 2 on our graph, and we know that there's origin symmetry in our graph, that means the x value and the y value are going to become opposite. So we're going to have the point negative 4, negative 2 on our graph with origin symmetry. So negative 4, negative 2 is going to fall right there. And again, that's a rotational symmetry. You can think about taking this graph and rotating it 180 degrees. Example 1, graph y equals 2x minus 3 by plotting points, okay? So we're going to start off with graphing by just plotting a few points. I know that y equals 2x minus 3 is the equation of a line. And we know that a graph is just an image of all of the solutions. So if we plot a few solutions to get the general shape of the graph, then we can extend our line through all of the points. So let's start with an XY table. All right, I like to pick negative 2 to 2. So negative 2, negative 1, 0, 1, and 2. And I'm going to plug those in. So let's plug in negative 2. So that's going to give me y equals 2 times negative 2 minus 3. Well, 2 times negative 2 is a negative 4. And negative 4 minus 3 gives me -7. So one solution of this equation is the ordered pair -2, -7. Okay, I'm going to go ahead and plug the rest of these in. I'm not going to show you all the work. -1, when I plug -1 in, I get 2 times -1, which is -2, and -2 minus 3 is -5. When I plug 0 in, I get 0 times 2, which is 0, minus 3 is -3. When I plug 1 in, 2 times 1 is 2. 2 minus 3 is -1. And when I plug in 2, I get 2 times 2 is 4, and 4 minus 3 is a +1. So then I'm going to go ahead and plot those points. Well, notice -2, -7 doesn't fit on the grid I have here. So what I'm going to do is I'm going to go ahead and I'm going to put -1, -5 as my first ordered pair. -1, -5. 1, 2, 3, 4, 5. Now, you're hand drawing your grid, so you can go ahead and pause if you want and make it so that the -2, -7 will fit on the grid if you want. Okay? Then I'm going to go ahead and plot the point 0, -3. 0, I start at the origin, and I just go down 3. Then I have 1, -1, so I'm going to start at the origin, go to the right 1, and down 1. And then lastly, I have the point 2, 1. I'm going to go to the right 2 and up 1. All right, so what I've done is I went ahead and I graphed on my graph 4 solutions to this equation. We know there are infinitely many solutions, okay? I just went ahead and graphed 4 of them. So what does that graph really look like? Well, if we connect those dots, we're going to get something that looks like this. Y equals 2x minus 3 is this line that extends in both directions forever. Okay, but I have 4 specific solutions drawn there. So that is what your graph should look like. Make sure that you go ahead and put an arrow on the end of your lines signifying that this graph continues on forever and ever. Now, a little bit later we're going to talk about x and y intercepts. So keep in mind, remember, right here is the y-intercept, and right here is the x-intercept. And those are going to be important values that we're going to talk about later. Example 2. Graph y equals -3 plus x squared by plotting points. Just like the last example, we're going to go ahead and make a little xy table. And you can start anywhere you'd like. Again, I like to do -2 to 2 to kind of get an idea. -2, -1, 0, 1, and 2. Now, I have an x squared in this problem, so I know that I'm going to be graphing a parabola. This is a quadratic, okay? So I know the general shape. So once I plot these points, if I don't have that general shape, I want to make sure to go ahead and pick some more points. So let's start with -2, okay? I'm going to write out the first one. So that's going to give me y equals -3 plus -2 squared. When I simplify, that gives me -3 plus a -2 squared is going to give me a +4. -3 plus 4 is going to give me 1. So my first ordered pair is -2, +1. Okay, I'm going to continue on. When I put -1 in, -1 squared gives me a +1. -3 plus 1 gives me -2. When I put 0 in, I get -3. When I put 1 in, I get -2. And when I put 2 in, I get a +1. So go ahead and plot those points. Again, take a minute and draw your grid or paste your grid in. -2, 1. So I'm going to go to the left 2 from the origin and up 1. -1, -2. I'm going to go from the origin, I'm going to go to the left 2, and I'm going to go down 2. I'm sorry, to the left 1 and down 2. Then 0, -3. I'm going to start at the origin and just simply go down to -3. 1, -2. I'm going to start at the origin, go to the right 1, down 2. And my last point, 2, 1, I'm going to start at the origin. I'm going to go to the right 2, and I'm going to go up 1. Make sure I got all my points. All right, so those 5 points fit on there nicely, and we can see that we're getting that shape of a parabola. Okay, so again, these are just 5 solutions to this equation. Okay, so I'm creating that image of all of the solutions. So what I'm going to do is I'm going to go ahead and connect those points, and it's going to look something like this. Okay, there's my parabola with my points. Okay, now that we have that drawn, again, I said later on we're going to focus on things like the x-intercept and y-intercept, so I want to point those out. Here we have an x-intercept, another x-intercept, and a y-intercept. So again, we're going to talk about those later, but you can see what we've created is an image of all of the solutions to the equation y equals -3 plus x squared. First, let's talk about x-intercepts. X-intercepts are where the graph crosses the x-axis. When you write the x-intercept as an ordered pair, it's always going to be the x value and 0. Okay? And then algebraically, when we're trying to solve for the x-intercept or find the x-intercept, what we're going to do is we're going to set y equal to 0. So we're going to plug 0 in for y and then solve for the x value or values. Okay? So if you're looking at the graph and you say, okay, what does the x-intercept look like? We talked about this before briefly. Here is an x-intercept. All right? The ordered pair for that point is the point 3, 0. Again, the x value in this case is 3. The y value is always going to be 0 if we have an x-intercept. Okay? So this could be the x-intercept for maybe a line. I know my line's not perfect, but that's an example of an x-intercept. So now let's look at the examples of y-intercept. All right, a y-intercept, very similar, but really the opposite, is where the graph crosses the y-axis. Okay, in this case, the x value is going to be 0, and then we'll know the y value. And algebraically, to solve for the y-intercept or to find the y-intercept, you're going to set x equal to 0 or plug 0 in for x and solve for the y value. So let me give you an example. Here is a y-intercept. Okay, again, we could have a line. This has a y-intercept here. The y-intercept is 0, -3. And this one also has an x-intercept. It's a fraction, so now we're not going to talk about it, but there's your x-intercept. Some equations have both an x and y-intercept. Some have multiple x-intercepts or y-intercepts. And then sometimes we don't have either, depending on the graph. Example 3. We're going to find the x and y-intercepts of 2x minus 3y equals 5. Okay? It doesn't matter which one you do first. Let's just go ahead and start with x-intercept. To find the x-intercept, if you recall, we're going to take the y value and we're going to plug in 0. Okay? We're going to plug 0 in for y. Because whenever we have an x-intercept, we know that it's on the x-axis, which means the y value is 0. So that gives me 2x minus 3 times 0 equals 5. If I solve that, that's 2x minus 0 equals 5, which leaves me with 2x is equal to 5. Divide both sides by 2, and I get x equals 5 halves. So my x-intercept is 5 halves. If I want to write that as an ordered pair, the ordered pair for the x-intercept would be 5 halves as the x value and 0 as the y value. Now you can write it as an ordered pair, or you can just say that x equals 5 halves. Now let's go ahead and find the y-intercept. For the y-intercept, we're going to plug 0 in for x. Okay, so that's going to give me 2 times 0 minus 3y is equal to 5. 2 times 0 is 0, so 0 minus 3y equals 5. That gives me negative 3y equals 5. I'm going to go ahead and divide both sides by negative 3. that gives me y equals a negative 5/3. And again, up here, I'm going to go ahead and write it. If I wanted to write that as an ordered pair, my ordered pair would be 0 for the x value, and the y value would be negative 5/3. So there's my x-intercept and my y-intercept. Remember, for x-intercept, you're going to plug 0 in for y, and for y-intercept, you're going to plug 0 in for x. Example 4, find the x and y intercepts of y equals x squared minus 3x minus 10. This time we're dealing with a quadratic, but you find the x and y intercepts the same way. So again, I'm going to start off with x-intercept. For x-intercept, remember, we're going to put 0 in for y. So that's going to give me 0 equals x squared minus 3x minus 10. Well, notice we have this quadratic equal to 0. If you recall back in previous sections, how do we solve something like this? Well, the first thing we need to do is when we have it equal to 0, we want to go ahead and factor. So take a minute and factor x squared minus 3x minus 10. The factors are going to be x minus 5 and x plus 2. Okay, again, factors of negative 10 that add up to negative 3. Once I have it factored and I have it equal to 0, remember I can take each factor and set it equal to 0. So I have x minus 5 equals 0 and x plus 2 equals 0. I'm going to solve each of those. So I'm going to add 5 to both sides in this first equation. That's going to give me x equals 5. And I'm going to subtract 2 over here. That's going to give me x equals negative 2. So my x-intercepts are negative 2 and 5. All right, so now let's go ahead and find my y-intercept. All right, y-intercept, remember you're going to plug 0 in for the x values. So that's going to give me y equals 0 squared minus 3 times 0 minus 10. So that's y equals 0 squared is 0, negative 3 times 0 is 0, and then we have minus 10. So that's going to give me a y value of negative 10. Again, you don't have to write them as ordered pairs, but if you wanted to, the x-intercepts would be the ordered pairs 5, 0, and negative 2, 0, and the y-intercept would be the ordered pair 0, negative 10. Now, I know that this was a quadratic, which means it would give me a parabola. So just to give you an idea of what that graph would look like, just from the intercepts, I know it's crossing the x-axis at 5. 1, 2, 3, 4, 5. Not the best graph. And it's crossing the x-axis at 2. And it's crossing the y-axis all the way down at negative 10. I know I'm having some crazy parabola that looks something like that. Okay, it crosses the x-axis twice and the y-axis once. Example 5. Find the x and y intercepts of 2x squared plus y squared equals 8. Remember, you know how to find x and y intercepts, so don't get confused by all these squares. First, pick one. Let's start with x-intercepts. For x-intercepts, remember that we're going to plug 0 in for y. So that's going to give me 2x squared plus 0 squared is equal to 8. That leaves me with 2x squared equals 8 because the 0 squared is just 0. And now I'm solving this, okay? The first thing I want to do is I want to divide both sides by 2. That's going to give me x squared equals 4. And then I can use the square root property, which says I can take the square root of both sides. So when I do that, I can take the square root of the x squared and the square root of 4, and I have to remember that I have to take into consideration the positive and the negative solution. So the square root of x squared just leaves me with x equals plus or minus the square root of 4. Well, that simplifies to x equals plus or minus 2. So I actually have two x-intercepts. So if I want to write those as ordered pairs, my x-intercepts are going to be the ordered pairs 2, 0, and negative 2, 0. All right, so let's try to find our y-intercepts now. Very similarly, we're going to go ahead and plug in 0 for x this time. That's going to give me 2 times 0 squared plus y squared equals 8. 2 times 0 squared is just 0, so that leaves me with y squared equals 8. Again, I'm going to take the square root of both sides, so square root of y squared and the square root of 8, but I have to remember to do positive and negative. So that's going to leave me with y equals plus or minus the square root of 8. But I'm not done yet because this 8 can be broken down. Remember that 8 is 4 times 2. So this really, the square root of 8 is equal to the square root of 4 times the square root of 2, which simplifies to 2 root 2. All right, so I want to write that as y equals the positive and negative 2 root 2. Okay, and again up here at the top of the screen, if you wanted to write those as ordered pairs, your ordered pairs would be 0 and 2 root 2. And the other one would be 0, negative 2 root 2. So we have two x-intercepts and two y-intercepts for this problem.